Bismillahirrahmanirrahim. Students, welcome to our fifth virtual session of this course, Introduction to Databases. So if you can hear me properly, please raise your hands. Okay, good. So in today's session, we are going to talk about entity relationship diagrams. We already studied this topic in our face-to-face class. A few slides, I think 2-3 slides were left about weak sets in entities. So we'll be talking about those, and then I'll be giving you an example to work on. Okay, now let's proceed with our slides. So during the execution of slides, if you feel any execution of my lecture, if you have any question, you can send me text message or raise your hand. So we were talking about entities and the relationships and how we model the such relationships in our lecture. A database can be modeled as a collection of entities and their relationships. An entity is an object that exists as is different from other. For example, a specific person, company, event, or plant, and every entity has certain attributes. For example, if people are entity, their names, addresses, IDs are their attributes. An entity set is a set of entities that of the same type that share the same properties. For example, set of all persons, set of all companies, these are entity sets. So all persons in a set will be sharing the same attributes like name, address, ID, etc. Entity sets of instructor is this, and entity structure set of student is this. All the instructors are sharing two attributes of ID and name, and all the students are sharing the attributes of ID and name. So these are two entity sets. The relationship between entities can be represented and can be written as in the form of relationship set. As I told you before that a student can be advised by instructor, so advisor is the relationship. Then I told you that how you can model the relationship by you can draw lines between two entities to represent the relationship, and you can add attributes to the relationships as well. For example, Crick is an instructor who is advising student Tanaka, and the relationship started on 3rd May 2008. Similarly, Katz is an instructor who is advising Shankar and Zhang, and the relationship started on 10th June and 12th June respectively. So you can add attributes to the relationship as well. Then the degree of relationships, the relationships can be binary and the relationship can be ternary, or it can be more than that as well, but most of the relationships in databases are binary relationships. The attributes, every entity contains certain attributes. For example, every instructor has an ID, name, street, city, salary, and every course an ID, title. So these are the attributes of every entity. The attributes can be simple or composite, can be single valued or multi-valued. These can be derived or computed attributes as well. Then I told you example of composite attributes which can be decomposed, like name can be decomposed as first name, middle initial, or last name, and same is the case for address. Then I told you about the cardinality constraints. I told you that the binary relationships we can map cardinality in one of the following ways, like the cardinality can be one-to-one, one-to-many, many-to-one, and many-to-many. This slide is showing you two types of cardinalities, one-to-one and one-to-many. So here you can see when one entity in entity set A is mapping to only one in the entity set B, this is one-to-one relationship. Then the next one is showing one-to-many. In one entity in entity set A is mapped over two entities in entity set B, two or more. So this is one-to-many. And some elements in A and B both may not be mapped to any elements in the other set. This is also possible. It means one-to-one or 1-to-0 can be there. Many-to-one and many-to-many relationships are here, where many entities in set A are mapped to many in the set B. And same condition is true for here. Like some elements in A and B may not be mapped to any other in the other set. Now the keys, super key is an entity set is a set of one or more attributes whose value uniquely determines each entity. I told you about candidate keys, and I told you about primary key. Like the database designer selects one of the key to uniquely identify each of the database record while designing. So the key which database designer is using is called primary key. I'm skipping some of the things because we have already discussed about these lots in the lecture. Okay, this is the ER diagram. In entity relationship diagrams, we model the entities at the sets through these rectangles. On the top of the rectangle, the name of entity is mentioned, and below it, the attributes are mentioned. The primary key is underlined, and the relationships is represented in this way, diamond shaped symbol, and the name of relationship is written over here. So instructor and student has advisor relationship, and they are linked to each other. You can write your composite multivariate and derived attributes in more details in your entities as well. So here you can see that how composite attributes are written, how multi-valued attributes are written, and like multivariate attributes are written, and how derived attributes are written. So if you want to add some details, some attributes with the relationship, you can do so. Like advisor relationship started at a particular date. You want to mention that date, you can mention it like this by using a dotted line. Entity sets of a relationship need not to be distinct, and each reference of an entity set plays a role in a relationship. For example, here the label scores ID and prereqs ID are the roles. Then I told you that how you can represent it in a diagram. So you use this arrow to signify one, and an undirected line to signify many between the relationships. For example, in one-to-one relationship, one instructor can advise one student, and one student can be advised by one instructor. So this is the one-to-one relationship represented through these arrows. In one-to-many, one instructor can advise many students, but one student can be advised by one instructor. So this is one-to-many relationship. So this is representing one, and this is representing many. But remember, so if you say many, it means 0, 1, 2, or many. Many to one means many instructors can supervise students. One instructor can supervise one student, but one student will be advised by many instructors, and it will be 0 or many. Many to many, in which an instructor is associated with several students, and a student is associated with several instructors. So one student can advise many students, and one student can be advised by many instructors. So both way it is many, so that's why we have used undirected line to represent this relationship. Then the participation of an entity set in a relationship can be total participation or partial participation. When every entity in the entity set is participating in at least one relationship in the relationship set, then this is called total participation, because every entity is participating. If some entities are allowed not to participate in a relationship, then it is called partial participation. This is an alternate way to represent the relationship. Instead of using arrow or undirected lines, you write it like this. So this is actually many to one, because this is representing one and this is representing many. The ternary relationships can be represented as well, where the relationship is linked to all three entities in this way. We allow at most one arrow out of a ternary relationship to indicate a cardinality constraint. For example, an arrow from project guide to instructor indicates each student has at most one guide for a project. If there are more than one arrow, there are two ways of defining the meaning. For example, a ternary relationship R between A, B, and C with arrows to B and C would mean each A entity is associated with a unique entity from B and C, and each pair of entities from A, B is associated with unique B. So to avoid confusion, we outlaw more than one arrow. Okay, so do you have any questions so far? If you have any question, please raise your hands. And if no, please tell me through text so that I proceed further. Okay. Okay, now let's talk about a topic which I skipped in my class. Weak entity sets. An entity set that does not have a primary key is referred to as a weak entity set. The existence of a weak entity set depends on the existence of identifying identity set. Please wait for a second. Okay, I'm back. The existence of a weak entity set depends on the existence of an identifying entity set. It must relate to the identifying entity set through a total one-to-many relationship set from identifying to the weak entity set. An identifying relationship means which is identifying it is depicted using a double diamond. The partial key of a weak entity set is the set of attributes that distinguishes among all the entities of a weak entity set. The primary key of the weak entity set is formed by the primary key of the strong entity set on which the weak entity set exists independent. So let's see the example. Now, we underline the discriminator of a weak entity set with a dash line because here you can see there are two entities, course and section. Now in course there is a primary key course ID, but in section there is no primary key. So when you want to mention a relationship between a weak entity set, a strong entity set, course, you do it through a double diamond and through a double line. So in section there is no primary key, but section ID, semester and year collectively discriminates each section. So we have underlined it with a dashed line. So this is the weak entity set. Okay, now you can see the CR diagram for a university enterprise. So in this diagram you can identify many things like entities. If you see entities are instructor, department, student, section, classroom, time slot, course. In all the diamonds you can see the relationships, like relationship of course department between course and department, department relationship between instructor and department, teacher's relationship between instructor and section, advisor relationship between student and advisor, takes relationship between section and student, and with an added attribute grade. So you can see here that there are many entities. For a university enterprise, for department you note down department name, building, budget, instructor ID, name, salary, section ID, semester, year. Now this is weak entity, and the relationship is section course, which is weak. So you identify all the entities, you identify their attributes, you identify their primary keys, then you identify the relationships, and then you also specify that what type of cardinality exists, like one to many, many to many, many to one. Like here you can see that one instructor can advise many students, right? So you can mention it like this. Similarly, you can see, if you see here, one department offers many courses, but one course is offered in one department. Similarly, a student, one department can have many students, but one student belongs to one department. One student belongs to one department can have many students. So in this way, the relationship between entities are mentioned. Okay, so is it clear? If you have any question, you can ask me. Okay, no question? So I'm proceeding further. Okay, I'm proceeding further. Students, during this virtual session, I mark your attendance randomly at any time. So make sure you attend the whole session, because if you are skipping for some time or leaving for some time, then you won't be able to, I won't be able to mark you as present. Because as I told you that this is automatically taken attendance, so at any moment, at any time during the virtual session, attendance can be taken, so be prepared for it. So no questions so far? So please tell me if it is no, so that I proceed further. Sometimes when you don't send me any reply, I feel like you are not listening or there is some problem. So keep telling me. This is the disadvantage of this virtual classes. I can't see your faces. Okay. Okay, good. Okay, now, so this is diagram. Now I have a problem for you. I have a question for you to do. So be prepared. Take out a paper and a pen. So all of you keep a paper and pen ready with you. You are going to do some activity. So are you prepared? If not, just go and bring a piece of paper and pen with you. Okay, so the question is, you have to construct an entity relationship diagram for a hospital. Imagine a hospital system. Now we are talking about our hospital management systems, an online system with a set of patients and a set of medical doctors. Associate with each patient a log of the various tests and examination conducted. So first of all, I want you to identify the entities in this system. Then I want you to note down some of the attributes of this system. Think about what can be the primary key, what can be the foreign key, what can be the other attribute, and can be the possible values. After identifying entities, I want you to see what kind of relationships can exist between patients, doctors, and if they are getting different tests and examinations, what are the possibilities? So I have this solution with me in the very next slide. So I want you to first think about this system and make your entity relationship diagram, and then I'll ask you question that which entities you have identified, and then we'll proceed further. So can you view the slide of question? Everyone can view it? Okay. Okay, now now I'm giving you 15 minutes. It's 6:26 according to my clock. So I'll be asking you. You have, you can take time like 6:40 or 6:45. Spend some time, think about it, identify entities, their attributes, and try to draw an ER diagram. So I'll ask you about it at 6:40. So take your time. Okay, students, can you hear me now? Please raise your hands if you can hear me. Okay. Okay, students. So have you made something? So have you identified entities? Okay. So let me show you the solution. So you were asked to construct an ER diagram for a hospital with a set of patients and a set of medical doctors, and then I asked you to identify the attributes above each, identify the entities, their attributes, and then I asked you to make it ER diagram. So this is the ER diagram, a not very refined one, but the basic ER diagram. Here you can see there are three entities: patients, doctors, and tests. And the attributes of patients are recorded in this way. Although it's not recorded in this way, in a diagram, relationship diagram, which I have told you, where you represent entities through a rectangle and mention all the attributes inside the rectangle. But here, this is another way of representing attributes, in which you represent them by the ovals, small ovals. So, patients has attributes. SS number, which can be the ID of patient, or just sometimes social security number or something like that. You can call it like patient ID. the name of patient, the insurance, if the patient has, date admitted, date checked out, these fields. And then we have to record certain details about doctor, like doctor ID, name, specialization. Then between patient and doctor, there is a doctor-patient relationship. So the relationship will be for all the treatments and all the services doctor is providing to the student, also to the patient. Then tests are performed by doctor. So the performed by relationship is between test and doctor. For test, you record test ID, test name, test date, time, and its result. So result is an attribute which can be anything. It can be a composite attribute as well, in which you can define all the attributes, all the sub-attributes, like blood CP, then other tests, other common tests which are performed, or some specialized tests as well. So you can write all types of results and tests over here. So there are three entities: test, patient, and doctors. These are their attributes, and this is the relationship. So patient test log is there for patients. Now here you can see that one patient can have many test log, but one test log will be for one patient only. One test can be performed by many doctors, and one doctor can perform many tests. One patient can consult one doctor or many doctors, and one doctor can see 0, 1 or many patients. So this is many-to-many relationship, this is many-to-many relationship, and this is, if you read it in this way, it's many-to-one relationship. So this is the basic ER diagram of the example I just showed you. So is the diagram you made is similar to this? So do you understand it now? So the people who made it correctly, please, correctly or partially correctly, please raise your hands. Oh, you forgot the test, Ramal. So the experiments was given. So how many of you made the diagram correctly? You modeled all the relationships. Please raise your hands so that I can know that how many people are successful in doing it. No problem. Okay. Okay, nobody raised their hand so far. I'm surprised that your diagram was totally different. Okay, no problem. So now you can see that this is the diagram of an actual diagram of the relationship you were asked to model. Now I have an important announcement for you. I told you in our face-to-face class that maybe you will be getting an assignment in this week. So you have an assignment in this week. I'll be posting assignment within few minutes on your blackboard. Just see it, and remember its submission deadline is Saturday midnight. So by Saturday night you'll have to submit this assignment, and I have already posted the assignments of system analysis and design over the blackboard. Just see, and you have 2 assignments this week, so go through all the contents. And remember, this studying and understanding this ER diagram is important because the assignment is about this entity relationship diagram. So please keep watching your blackboard announcements and assignment section. So there is an assignment coming on your way within a short while. Okay? Okay, now I'm going to turn the recording off now, and if you feel you have any question, you can ask me through the text panel, and then I'll answer your question. Thank you very much.